Sorry about the wind.
Hiya, I'm Mick, also known as Mike. This video is to see if it's possible to build a Great Pyramid and also complete the reef. In the previous videos I demonstrate with small scale models how to pull weight up ramps and suggest a way in which to build a Great Pyramid. If you've already watched the previous videos and found them interesting, I hope you enjoy this video as well. This video is what I call the real deal. Music: Paul Johnston. Prater's Theory. The real deal. Moving on to the real deal, this is where it got scary for me. All my efforts and those years of my life bundled up into one final action and final emotion. Building the pyramids. Today,
Part 3.
I was thinking, would the fly on the wall syndrome have some effect? Or was the whole theory flawed from the start? Scary. One thing I've always said since childhood, proof is in the pudding. So I figured out you could easily die wondering because it wouldn't matter. But I could not live and continue to wonder. So I got on building the ramp, 90-degree platform and rig. I decided to build a ramp of around 8 metres long, consisting of a 7.5 degree slope. This is because I knew this gradient would get very close to the top of the Great Pyramid and later worked out that it would reach the very top if supported by the casing stones. And the main reason I knew this gradient would be challenging in terms of the load being brought up.
136 kg.
This was me pulling 4 blocks weighing 34 kilograms each and the sledge up for the very first time. I was hoping the roller spacings were right. There was a lot of stretch on the small rope pulling the sledge. I then take off the guide rope ends from the last roller. These then wrap around the rollers to make the load more stable whilst travelling on the platform sledge. The same is done at the other side. This is what I call the C-hook. It would normally be hooked over the rear end of the block, but I just hooked it over the side of the sledge and rope. The platform sledge pulled easy. This setup is to demonstrate that blocks can be moved 90 degrees to the ramp and then moved off the platform sledge onto another ramp. This showing any angle of travel is possible. As you can see, I'm happy at this stage. Pushing back the platform sledge was so easy. I then put the guide ropes back in place from the top roller. Next I set up the downhill rollers. I put a piece of a 4-inch nail which was cut with a hacksaw taped to a bit of string underneath the rollers. I would have liked to use something better, but pieces of nails was all I could think of to make it simpler at the time. I was getting ready to lower the blocks on my own. Lucky enough, a friend turned up.
This is where it'll start going over.
This made me realise I would not like to lower a large load. Mind you, I should have had a rope pulling the sledge downhill.
You can on that roller will be right, I think. That roller went out of turn.
The spool's turning a little bit at the top.
Yeah, that's what you want.
Under the sledge there are 2 tea towels wrapped up in a roll. This ensures every roller is active so one does not get left behind. The second and third roller have no guide ropes for safety reasons, and unfortunately rotated the sledge at the bottom. One man pulled 272 kilograms or 0.27 tons. We straightened up the sledge but didn't set the sledge in the right position. 8 blocks are being pulled, which in total is slightly over a quarter of a ton. James pulls well and actually moves the load up the ramp for a short distance, pulling with both hands. When he comes to getting more up, holding it in one hand, the sledge rolls backwards. This shows me that pulling a rope could be more than a one-man operation. Listen to the spool's guide rope stretching and the axles slipping. Watching this and listening to this, I have to ask myself, what type of rope would I need? Would a cog system on the spool's axle be better? Or maybe a larger diameter axle to reduce this pulling effect? Using the spool's smaller circumferences for drawing up the sledge would make it far more easier, but I try not to go this way in the theory and stick to using one circumference on the spool. Note the angle of the rope from the sledge to the spool. Would this make any difference? In part 1, the small lattice bedroom model test rig achieved 20% more than the A-frame, so I thought that twice the amount could be pulled up by one man. I was certainly disappointed it didn't work as expected.
Failed.
But James seemed more disappointed. I had to return to the bedroom models. I roughly set up a 7.5 degree slope and with a similar setup to the real deal achieved 13 tonnes for a theoretical 2.25 tonnes.
2.25 T. And here's 13 tonne.
Testing the small bedroom model, the angle of the rope from the sledge to the spool did not make much difference. This was even testing it from the pulling source. Even after testing this, I still had to assume that the angle of the rope from the sledge to the spool must play a part in pulling up a load in the real world. The main thing other than the stretching of the rope to the sledge was the stretching of the rope to the spool, so I tested this using bits of rubber elastic on the guide ropes. The difference was only slightly noticeable on this thick elastic. Maybe the garden model suffers from a combination of the stretching of the rope, the angle of the rope from the sledge to the spool, and the technique used in pulling. In any case, I think with all these issues ironed out, one man still would only be able to pull slightly over a quarter of a ton up the 7.5 degree slope. This means, based on the garden model figures, a 40 ton block would take 148 men. At this height, 103 metres, 347 feet, and a ramp length of 57 metres, 187 feet, with men spaced at a distance of roughly 750 millimetres, 2.5 feet, 152 men could fit on this ramp. This is having 76 men either side of the rollers. 160 men shown here. So that would also mean it's not impossible to bring a 40 ton block up to this height of 103 metres, 347 feet from ground level. At this height, 117 metres, 406 feet, a 30 ton block would take 110 men. That is around 16 men that would not be able to fit on this 35 metre, 115 feet ramp. Even so, it would not prevent the 16 men from pulling down from the opposite end of the rig down the outer wall. The top inner section of the Great Pyramid is made up of small blocks in the 2.5 ton range. In the theory, I use a 13 degree ramp at this height. If the ramp section was taken away and got replaced by a 7.5 degree ramp, then it would reach within 13 metres from the top. This is at a width of 5 metres, as shown here. If the ramp at the top was 3 metres wide, changing to 2 metres wide, and then 1.5 metres, or left at 2 metres wide approaching the summit, then the 7.5 degree ramp would be within 5 metres from the top. This means if one man can pull a quarter of a tonne, then the idea is feasible, and we were not too far away from doing so.
But for now, all my efforts and those years of my life.
Will it really work?
Well, that's something you're going to have to find out in the next video. But before I go, I'll show you what I've found revisiting these videos.
If the 7.5 degree ramp was supported by the casing stones on the outside of the Great Pyramid, the ramp would finish above the last casing stones. Perfect for the cap. This is starting at ground level. I became aware that the present day blocks on top of the Great Pyramid are not all aligned in a north, south, east, west direction, as I originally thought. The outer blocks do, but the inner blocks are slightly offline. If I take the outer spiral picture and flip the image, place it under the other picture, you can see how closely the lines of blocks relate to the plan view on the ramps. I spent nearly a full day sat on the sofa gazing at this image, trying to work out a pattern of block placement. The pattern showing that men do not need to stand on the rollers to bring the block into line.
Anyway, I'll end with a 1 minute animation. It took me 4 weeks to do. Whilst watching this, think of all the time it's taken me. A light would go a long way to keep me going. Anyway, that's it from me. Bye from Mike.
Music, Sean Plowman, stroke Shedman. Thanks for watching.